Okay, so this is part 2 of connected particles, and we're going to look at example 12. This is in my PowerPoint and it is in the book. It is a really good example to go through. It is tricky. This is basically the only thing I'm going to do in this video is go through this example 12. And there is a video made by Mr. Bennett as well, which I'm going to email you to have a look at. I'm going to give you a couple of questions then to do. So, example 12. So this is on page 170, so have that example in front of you, please. And it says you've got a light scale pan. This is your scale pan here. It's light, therefore we don't need to worry about the weight. It's attached by a vertical light inextensible string, so the acceleration is going to be the same all the way through, and it's light, so we don't need to worry about the mass. And there's two weight masses here, A and B, on top of each other, and the scale pan is raised, so there's going to be a force here. There's going to be tension in the string going upwards. So I'll call that T here. And it's raised vertically using the string with acceleration of 0.5 meters per second squared. And the first question says find the tension in the string. So I'm going to look at the whole system, and I'm going to resolve going vertically upwards for the whole system. Okay, so we're going to resolve going upwards in the same direction as the acceleration for the whole system. So what forces have we got acting here? Well, we've got the weight of these two together. So that's 1 kilogram. So my weight going downwards will be 1g. Weight is mass times acceleration, which is due to gravity, 1g. So that's my weight going down, and all I've got going up is my tension. I have got normal forces in here, but because I'm looking at the whole system, they will cancel each other out. Right. So, if I look at doing F equals ma on the whole system, I've got T going upwards, I've got 1g going downwards, the whole mass is 1 kilogram. Remember, mass has to be put into kilograms times the acceleration of 0.5. And if I work all of that out using G as 9.8, I will get T to be 10.3 newtons. So that's not the tricky bit. That's fairly similar to what we were doing in part 1, except we have to think about the force downwards as the weight. Okay? Now, next question, part B of this same example, asks to find the force exerted on mass B by mass A. So the force exerted on mass B by mass A. Now, so we've got our diagram where it is, and we can't consider mass B on its own at this point because the scale pan is also acting on mass B, and we don't know the size of that force. But the force exerted on mass B by mass A will be the same as the force exerted on mass A by mass B. Okay, so let's just look at mass A for the moment. So I'm going to look at the forces on A. I'm just going to sketch this diagram out again and just concentrate on what is happening at A. It'd be really good to look at my PowerPoint as well, because the PowerPoint does explain all of this as much as I am explaining it now. So you've got your mass A here of 0.4 kilograms or 400 grams. We've got our normal reaction R of B acting on A. So we've got B underneath it. Okay. So this normal reaction R is the force of B acting on A. And it's all accelerating upwards with an acceleration of 0.5. That hasn't changed. And we've also got, acting on the forces on A, we've got the weight of A, 0.4 g, going downwards. Now there's nothing else acting on A. So we've got B, the normal reaction of B acting on A, and we've got the weight of A going downwards. So if we look at F equals MA, and we're going to resolve going this way just on A. Resolve on A only. So we're going in the upwards direction. So we've got R, our normal reaction, minus the weight of A equals the mass of A times the acceleration of A. And if you work all that out, you will get R to be 4.1 newtons. So the force of B acting on A is 4.1 newtons. This will be the same, this is going to be the same as the force of A acting on B. So, because the two masses are staying together, and that's why we have that. And that was the question B, was asking you to find the force exerted on mass B by mass A. So this is going to be my answer here. Now I think that is quite confusing, and I think you need to look at that again, and I'm going to get you to look at another video to explain more examples on this. Okay, so part C. Part C asks to find the force exerted on mass B by the scale pan. So what we're going to look at now, so part C, the force exerted on mass B by the scale pan. So let's look at what's happening here with B, A, okay, and we've got our scale pan here. So we've got, with B, I'll just change my colour, we've got 0.6 g going downwards, the weight, because the mass is 0.6. We've got a reaction of the scale pan acting up onto B. If we call that, let's call that P. And we've also got the force of A acting on B, which we worked out in the last question to be 4.1 newtons. And the whole thing is accelerating upwards with an acceleration of 0.5 meters per second squared. So let's look at this again. I've got the weight of B going downwards. I've got the force of A acting on B going downwards. And I've got the normal reaction of the scale pan on B going upwards. So if I resolve going on B vertically upwards, I have got F equals ma. Forces going up will be P. Forces going down are the weight and 4.1 equals the mass times the acceleration. And if I work all of that out, I will get P to be 10.3 newtons. Right, now I think it would be a good idea to watch that video again. And I would then like you to listen to the video that Mr. Bennett has made on question 7 from 10E, which is this question here. They are two particles A and B. They're connected by a string, and B hangs directly below A. So it is again the vertical motion. So I'd like you to listen to that video. And then I would like you to have a go at question 4 and question 6 on page 171. And then there's a couple of challenge questions from the review exercise 2 on page 168. A lot harder. So if you're finding these too difficult, don't go on to here. However, if you find question 4 and question 6 fairly straightforward after listening to this video, then have a go at the challenge questions. Okay, thank you for listening. I hope that was not too hard, and take care and have a good day.